Hi, this is Paul Proyas with Metaphase Lighting Technologies, and this is an application note on line scan versus area scan. So this is a slide of what we'll be covering on this application note if you want to look ahead or skip ahead, but we'll only take about 3 to 5 minutes to go over the topic, covering all of these things here. Okay, so area scan versus line scan. First, to just give a little definition, area scan, it's using a camera to capture a 2D image of the entire field of view at the same time. So you have one camera, you have one or multiple lights, and you're taking a picture of the entire image in 2 dimensions, your length times width. Whereas line scan cameras will capture a series of narrow slices, maybe as small as 1 pixel at a time, and you'll move the camera over the object, or you'll move the object past the camera, capturing one line at a time, and then you'll be using a computer to reintegrate those images into one. And you can take a look on the right side here. We have an area scan example, and on the left side is a line scan, where you would either have the camera moving or the object moving. There are many applications where area scan would be the best choice. And normally most people would turn to area scan first, because if you can get the right image quality and the right signal to noise ratio using an area scan camera and area scan light, you're probably not going to look to a line scan solution. So some of those applications are for quality inspection of printed circuit boards, if you can get the reflection down, optical character recognition, which you would see a lot with license plate cameras, defect detection and a wide variety of manufacturing applications, and then robotics and automation, where you're using object recognition, localization, and tracking. So all these would be a good place to start with area scan. There are some situations when you might want to consider line scan over area scan, and a few giveaways would be anytime you're dealing with a web application, so continuous fabric or plastics, anything on rollers going by a camera. Anytime you need a uniform light, and that's been very hard to achieve over a large object, things like an underbody of a car where there's so many different shadows that trying to get one picture of that underbody, because it's so big and so many different shadows from different lights that you would need, is impossible. That's where line scan might work very well. Again, very large fields of view where it's just hard to capture one picture. And then anytime motion blurs an image, and you cannot use strobe. So if the situation, maybe you're around other workers and strobing a light just isn't feasible to stop that motion blur, then you may want to consider line scan. So line scan has several advantages and disadvantages. For the advantages, motion is not an issue, and often if you have motion, it can lend itself to line scan better than area scan. Light uniformity is easy to achieve because you're dealing with one row of the picture at a time. So with area scan, where you're worried about all the different shadows and getting the lighting just right, not really an issue with line scan. It can handle very large objects and continuous moving webs, and you can often get higher resolutions due to the higher output of the lights used in line scan. Now the disadvantage is it can be more complicated to implement, and we know there's a lot less people turning to line scan because it is more difficult, often requires a system integrator, it does require an encoder, and you need advanced software to create the raster image. There are a lot of different applications that line scan is well suited for. So anything with web inspection on continuous moving webs, plastic, fabrics, very good for that. Surface inspection, a lot of different things in transportation and logistics. Inspecting extrusions, you have just one uniform piece that's constantly being extruded out that can move past the camera, or anything that needs higher resolution. Other things that we have seen is train rail inspection. As the train is going by, you can mount lights and cameras to it, and it can look at the rail over miles long, where it wouldn't really be practical to do that with an area scan camera because you don't know what the image is going to look like. But when you focus at one line of pixels at a time, you get the light just right, you get the camera focused on that, you can then inspect something that is miles long. We've seen it on things like sausages, where you just extrude the sausage out and you're looking at 1 pixel at a time. Wafers, we've seen applications there too, where you just have very large silicon wafers and everything's reflecting and you can't get one area scan camera or the lights just right. You can do that with line scan and really reduce that reflection. There are a lot of different line scan applications out there, so there's a lot of different lights that are needed for that. And Metaphase has an entire family of line scan lights, and we want you to know that you can have every type of lighting technique that you have in area scan within line scan. So we have our UL line light, which is your standard line light you would use from a close distance, maybe 75 millimeters away. You can use it as front lighting. We have it with a diffuser that can be used as backlighting. We also have a diffused axial line light that is just like a coaxial light, where there's a reflector on there. The camera can go right on top, and then you're looking at an image with a diffused light coming down on it. We have collimated line lights, so if you need working distances of a few inches or even a few feet, that will still work. Our compact diffuse tube, it's a dome light in a line scan, so the exact same effect you get from dome lighting, you can get in a line scan application. Oblique line lighting, you can get dark field illumination with line scan, just as you would in area scan. And then our eclipser, that's kind of unique. It's for glass inspection. If you inspect glass at a certain working distance away, if there's any imperfections in that, it would reflect out, and you can use that for glass defect detection, which can be very difficult in area scan and even in line scan applications. So there's just a lot of different applications out there, and we have a lot of different solutions for that. Now, I know this is a recording, so you can't ask me any questions here, but we're always available to help out. Please reach out to your technical sales advisor anytime you have questions, or you can find us on metaphase-tech.com or email us at sales@metaphase-tech.com, and we're always happy to hear from you and provide any type of technical information that you need or any assistance you need with your application. Thanks.